And we are live. Well, you guys, I guess we're in lockdown for 2 weeks at least, so no place to go but just to stay home and get our math homework done. Aren't we lucky? So, first of all, before we do a whole lot, I want to show you progress of the class. So when we're done with this chapter, you guys can see that most of you guys are doing your work. There's a few of you that aren't doing anything, but you know, I'll get a hold of those parents I've been calling. But those grades will go in the grade book when we're done with this chapter, which is actually pretty soon. So you will see a change in your grade, and it should help, because this is all going in as A's if you're doing all your work. So first of all, let's take a look at the homework, okay? Yesterday's homework, we had graphing and finding the solution by graphing. So I will show you what the answers are. Now, mine aren't graphed because I just took the answers, but you need to graph them. So if you graph these two graphs, they do intersect, and the x value is 4. Number 2, same thing. If you graph these, you can see real quickly if I started at -4 and went up 1 over 1, up 1 over 1, up 1 over 1, and started at 0 and went up 3 over 1, but backwards to that, 3, 1, and then 3, 1 like that, that eventually these two lines would intersect right there. And that has an x value of -2. Okay, so this is how you do it. So number 3 has an x value of -1 if you graph both. I didn't. You need to. Number 4 has an x value of 2. Number 5, they're parallel lines. One starts at 6 and down 3 over 1, so it kind of goes like this. And this one starts like here, and then they're not going to graph at all. No solution. This one's the same line, and therefore something like this. Let's see, that'd be a -14, so they kind of go like this. They're going to graph like this, and then the other one's going to graph on it. So it's the same line, infinite many solutions. Okay, so that's the homework. Okay, now let's move on into the lesson. All right, today we're talking about, let's see, what is it? 3/24 2020. We're talking about graphing inequalities. Graphing inequalities. Alright, so the inequalities, that's our greater than or equal to, our less than, and our less than or equal to. Okay? So when you graph these, there's going to be a lot of solutions. Let me start with an example, okay? If I have y, example 1, I have y is less than or equal to a -1/2 x plus 1, okay? Now, what I want to do first is just graph the line, okay? So I'm going to graph the line. I'm going to get out my ruler, and I'm going to go ahead and graph this line over here. Put my y-axis, my x-axis down. And I'm going to go ahead and graph it, start at 1, because it's my y-intercept, and I'm going to go a slope of down 1 over 2, down 1 over 2, go down 1 over 2, down 1 over 2, okay, so forth and so on, and I'm going to graph my line, okay? Now, this one's different. I'm saying y is less than. Well, what I'm looking for is all the points that are less than this line and equal to. So on all the points. Now think about that. So this point right here, let me go ahead and put something down, okay? This point right here, it's less than. This point right here, let me get a green pen. This point here is below the line. It's less than. This point here. In fact, there's so many points that are less than this line that you can't possibly put them down. So we shade our area, everything below, because it says less than, everything below the line. Okay, so I'm going to shade and shade and shade, but that shows that all of these points are less than. So let's test a point, okay? Let's test a point. So the question is the point, let's say 2, 1, a solution? Well, from the graph, 2, 1 is not. But we can also plug that in and prove it. Okay, so if I take, every point's got an x value and a y value. If I plug in my 2 in for x and my 1 in for y, I'll rewrite this as, I'll put the 1 right there. 1 is less than or equal to negative 1/2, and I'll take the 2, that's an x, and I'll put it right there for the x, plus 1. I've got 1 is less than or equal to, let's see, half of 2 is 1. I get negative 1 plus 1. I get 1 is less than or equal to 0. Is 1 less than 0? No, that's not true. No, no, no. And we already knew that 0.21 was not a solution. So this proves it, okay? So let me show you a second example, okay? Second example, I have example 2. So I have an x plus 2y is less than or equal to 4. Is the point negative 1, 2 a solution? Okay, so we have two. If they're asking only for this question, is it a solution? They're not asking to graph. We've got two choices. We could graph it, or we could look at it, or we could just plug it in. Okay, they're not asking us to graph it, just saying is a solution. So, all right, it's a lot faster if they're asking just this question, is to plug the negative 1 in for the x. Let's plug the 2 in for the y, and let's see if it is less than or equal to 4. Okay, so I'm going to do that. So negative 1 goes in for x, negative 1 plus 2, and instead of writing y, I'll write 2. Is that less than or equal to 4? Well, let's keep going. That's negative 1 plus 4 is less than or equal to 4. I get a 3 is less than or equal to 4. Is that true? Yeah, 3 is. So that means that if we were to graph this and shade like we did up above, we would see that this point would be in the shaded region. So we can say yes. It's a solution, okay? All right, now let's do some graphing, okay? So let's start off with some easy ones, okay? I'm going to turn my page. If you want to pause it anytime you can. So turn the page. I'm going to go on to example 3. Okay, I got a few examples today. Hopefully this is not hard. Okay, example 3. I'm going to have, I want us to graph this. I'm going to graph y is greater than x plus 5. We're just going to graph it. Okay, so if I have to graph this line, I put my x and my y-axis. I know my y-intercept is up at positive 5, so I'm going to go up to 1, 2, 3, 4, 5, because that's my y-intercept. My slope, there's an invisible 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, and of course, up 1 over 1, I can keep going the line because the line's going forever. I'm just going to go ahead and do that, okay? Now, I'm going to be careful because there's no equal sign here. There's no little equal. So it says I want everything greater than. I want everything above the line but not equal line. Okay, now this is important. There's no equal sign here, so we do not draw the line, okay? Okay? Do not draw line. But I got a dashed or dotted point so I know where the line is. Don't draw a line because there's no equal, okay? So now, it does say greater than. So everything greater than the line, that's above the line, I'm going to shade. So think about this. Under the line would be less than, above the line is greater than, okay? So I'm going to shade everything above. So these are all of the solutions because I want everything greater than the line. It's a lot of them, so just shade it nice and dark. And that's my solution. That's how I do it. All right. Let's look at another example. Okay, two examples. I'm going to do example 4 and example 5 I'm going to do together, okay? Example 4, I'm going to have a y is less than 2. And example 5, I'm going to have x is greater than or equal to negative 1. Okay? Alright, now these are unique and special lines. Alright, so again, I'm going to go ahead and graph these. And I'm going to do my x and y axis here. Same thing here. Again, if you need to pause the video at any time, go ahead. And now the y equals lines are horizontal. Y is always equal to 2. So I'm going to go to the value of 2. And I'm going to go ahead and go up to 1, 2 right there. And y, there's no slope. It's a zero slope, so I'm going to go straight across. Now, I'm going to make it a dashed or a dotted line, again, because there's no equal sign, okay? This says less than, so I'm going to shade everything under the line. Alright, so I take my marker and I shade everything underneath or below the line, okay? There you go. That's it. These are all of the solutions. Every one of these points. This point's a solution, this point's a solution, this point's a solution. All of these points are solutions. That's why we shade the whole thing. Nothing up here, because we want less than 2. Okay, example 5 is an x equals. So to do an x equals, that's going to be a vertical line. So at -1, I'm going to draw, in this case, a solid line. Okay, I'm going to make it solid because there's an equal sign here. So I go to my 1 and I'm going to make it a vertical line because it's an x equal. So I'm going to go and just make it a nice solid line because it equals the line. And in this case, we want everything greater than -1. Well, greater than -1 would be all of this value. Okay, greater than would be like 0, 1, 2, 3. So I'm going to shade all of this. Okay. Okay, how am I doing? Hopefully really well. Okay. Okay, finally, last example, and then I'll give you the homework. Okay. Here's my last example. Example 6. Okay, I have a 2x minus 3y is greater than or equal to 9. Okay, if I want to graph this, the first thing I'm going to do is I'm going to solve for y. Okay, I want to graph this, so I got to solve for y. Alright, so I got to get y by itself. So first let's get rid of the x. So I'm going to get rid of the 2x. I'm going to go minus 2x minus 2x. Okay, if I do that, that's gone. Slide down the -3y. Keep your sign. Think of it as an equal sign. Greater than or equal to 9 minus 2x. You cannot subtract these. That's a whole number, and that's an x value. Okay, can't subtract these. Okay, now I got to come here. Still want to solve for y. So divide by -3, divide by -3, divide by -3. Okay. All right, that'll cancel out the 3 and the negative. And I'll have y by itself. Now, hopefully somebody's going to say, hey, Mr. Davies, you just divided by a negative, so you got to turn the sign. Turn the sign because I divided by a negative, so I'm going to rewrite this as, instead of greater than or equal to, less than or equal to. Okay, I got to turn the sign because I divided by a negative. Now, turn the sign. 9 divided by -3 is a -3. And then this is going to be my slope. This is going to be my slope. I'm going to have a positive, because negative divided by negative, positive 2/3 x. Okay, now, we did all of that. We solved for y. Now we're ready to graph it. Okay, I can do that. Get my ruler out. Get my pen. Draw my y-axis. Draw my x-axis. I'm going to start down at -3 for my y-intercept, and I'm going to go up 2 over 3, up 2 over 3. I'm going to run out of room, but that's okay. I can just squeeze it in like that. Okay, and I have an equal sign here, so I'm going to make it a solid line. And since it's less than, I'm going to shade below, because it is less than. So I shade below the line I just graphed, and it's all of these points down here. Okay? Alright, there you go. Now, great job. Homework today. Here's what I want you to do. Okay? And I need you to graph them where it says graph, but I want page 150. And I'd like you to do 1 through 19 all odd. I'm sorry, 1 through 19 odd. So don't do the evens, cross out the evens, okay? Now, if we look at the first problem, you don't need to graph. You just plug it in. There's my x value, there's my y value. I'll plug the 3 in for there, I'll plug the 2 in for there. Is 5 greater than 5? No. It's equal to, but not greater than, so that's a no. See how that works? Okay. On 7, you're just going to graph and shade. Okay. So on 13, graph and shade. 15, you have to solve for y first. And then graph and shade. Don't forget to flip the negative because there's a 1 here and a 1 there. Same thing on 17, you got to solve for y first. And 19, I kind of gave you a little hint. They're talking about digital cameras and cell phones. Make a profit $100 here for digital, $50 profit, and you want to make at least $300. So see if you can solve for y. You have to solve for y and graph. Okay? All right. Good luck. Get it done and send me your results. Good job, everybody.